Hello, welcome to this tutorial. Let us check how to use the EKS Cluster Access Management feature for the EKS Cluster authorization. For this demo, we will create one EKS cluster, create access entries and access policies for two users with different permissions, test their access. Finally, we will delete the cluster. In December 2023, AWS unveiled a new addition to Amazon EKS authentication known as EKS Cluster Access Management. With this feature, we can administer and grant access to different entities by using the AWS API instead of using the AWS Auth config map. EKS version 1.23 and beyond support the cluster access management. The two new terms introduced with the EKS Cluster Access Management are access policies and access entries. Access policies are Amazon EKS-specific policies that assign Kubernetes permissions to access entries. Access policies are not AWS IAM entities. They are defined and managed by Amazon EKS. You have the flexibility to grant an access policy either at the cluster level or the namespace level, mirroring the distinction between creating a cluster role and a role in Kubernetes terms. An access policy comprises a predefined set of Kubernetes permissions managed by AWS. Access entries are added to a principal. When providing access to an AWS principal for a particular EKS cluster, you establish an access entry dedicated to that principal. Subsequently, you can allocate permissions to the principal by associating the access entry with Kubernetes groups or access policies. Kubernetes access management is controlled by a cluster-wide setting known as the authentication mode. In EKS cluster, there are three authentication modes. Config map. In this mode, the control plane exclusively relies on the AWS Auth config map, and the creation of access entries within the cluster is restricted. API. This authentication mode entirely ignores the AWS Auth config map and focuses only on access entries. API and config map. Permissions authorized in both the AWS Auth config map and access entries are taken into account. However, if an AWS principal is mentioned in both an access entry and the AWS Auth config map, only the permissions granted through the access entry are considered. You can change the modes by using the Manage Access option in the access configuration. But switching authentication modes on an existing cluster is a one-way operation. You can switch from config map to API and config map or API. And from API and config map to API, not the reverse order. We will create one EKS cluster for this demo. I am creating a cluster with minimum configuration and I am using the EKS CTL CLI. The EKS CTL create the necessary resources by executing two CloudFormation stacks, one for cluster and other one for node group. The stack creation takes some time and we will pause. The stacks are created successfully now. Let us navigate to the Access tab and verify the authentication mode. Our cluster support both EKS API and config map authentication. We can also view the IAM principals, including the shadow administrator under the IAM access entries. We can update the authentication mode if we wish to change it. But remember, as mentioned earlier, the switching of the authentication mode in existing cluster is a one-way operation. We cannot switch back to config map option. If API mode is enabled, we can see Shadow Administrator and EC2 instance profile in the console in addition to other IAM principals. In config mode, we cannot see these IAM principals. We will verify if all the Kubernetes resources are ready. Let us list the EKS access policies with AWS CLI commands. These are predefined policies specific for the Amazon EKS. They are not AWS IAM policies. For this demo, I will create two IAM users. I am creating the first IAM user with name cluster admin. This user will be granted the administrative access to the cluster. I am also generating the access key and secret key for this user to switch to this user's profile for testing. Next, I am creating an access entry for the cluster admin user. Access entry is a resource in EKS, and we will add this to the user. We will then add access policies to this access entry to grant access permissions to the user. Access entry need to be created for each IAM principals when we use the cluster access management. Next, I am associating an access policy and attaching it for the cluster admin user. The scope type in the association is for the cluster demo cluster. The policy will be attached via access entry we created earlier in the backend. I am attaching the policy Amazon EKS Cluster Admin Policy. As the scope here is cluster, this is similar to the cluster role in Kubernetes. Let us go to the EKS cluster and check under the Access tab. We can see the cluster admin user is added to the IAM access entries of the cluster. We can also confirm the access policy is attached to the cluster admin principal with AWS CLI command. Now, I switched the AWS profile in the terminal to that of the cluster admin user. The next commands I will be executing as the cluster admin user. I am executing kubectl cani command to verify the user's permission. I am checking if the current user, that is cluster admin user, can delete pods in all the namespaces. The command returned yes as cluster admin user was created with administrator access. Next, I will create a new user who can access only one namespace. I switched back to my original user profile. I am also creating a new namespace with name demo for this purpose. I am creating a new IAM user and name it as namespace viewer. I will attach the view-only access to this user later. I am creating the access key and secret key of this user for testing the access later. Now, I am creating an access entry for the new namespace viewer user. Access entry is needed as we add EKS permissions to the user via access entry. Next, I am associating access policy to the namespace viewer user for the demo cluster. We will attach the Amazon EKS view policy this time and the access scope is limited to a single namespace. We need to pass the namespace name also. This scope is similar to the role in Kubernetes. Kubernetes roles are tied to a namespace. We can see the new user listed under IAM access entries in console. Now I have switched the profile in the terminal to use the profile of namespace viewer user. The next commands I am going to execute will be executed as namespace viewer user. I am using the kubectl cani command to test the access. I am trying to see if the current user has permissions to delete pods in all namespaces. The answer came as no. Next, I am checking if the current user has list access across all the namespaces. We added the EKS view access to this user, but we limited the scope of the access only to the demo namespace. The answer came as no, as this user cannot list pods in any namespaces other than demo. Next, I am checking if the user can list the pods in the demo namespace. The answer should be yes, as we created this user as a view-only user and the user has permission to the demo namespace. The answer came back as yes, as expected. The above demo shows how to use the EKS Cluster Access Management to grant different access levels to different users. If we were using the config map, we had to create users in IAM, then add them in AWS Auth config map, then we would need to create Kubernetes roles or cluster role and add those roles to users or groups defined with role bindings. Now with EKS Access Management feature, we can handle the user permissions with only AWS APIs. We have to work only on one place to define the access levels. There are generic EKS access policies available for us, and we can use them in cluster or in namespace scope. When more granular permissions are required, you can also map access entries to Kubernetes groups. You can use API and config map authentication mode for this purpose. For cleanup, we will delete the cluster with EKSCTL CLI. The command will delete the cluster and associated resources by removing the stacks. The stack deletion may take some time. Next, we will remove the access entries created earlier with AWS CLI. You can also remove the users created. As they have access and secret keys, you need to disable the keys first, then you need to delete the keys before deleting the users. Also, please note that we created IAM users and added only the EKS access policies. We did not add any IAM policies to the users. The users can manage only Kubernetes resources, not AWS resources in this case. Thank you, and we hope this video was informative.